So the plan is I want to modify the head of my R unit here to add an extra LED to it, similar to the mod that I did for my BB droid from a while back. So I haven't planned this ahead. I'm just going to sort of figure it out as I go. First step is to get the head off, which I believe I just push it off like that. There we go. Okay, I can put this off to the side, I think. And we see 5 connections here. Now, I know there are 3 LEDs in the head, so there will be 3 connections that run off to each of those LEDs. One will be ground, or maybe 2 of these pins are ground. I'm not sure. I'm going to have to sort of figure that out as I go along. You can see there's these covers here, these plastic covers. The wires that come from this connector are going to run up this shroud here and connect to where these LEDs are here. There's one here, and then there are 2 in here. So where can I put another LED? My BB unit has an LED right up here. On the R unit droids, I can't really do that, or I shouldn't, because you can see that there's a hole here for accessories. If I put an LED there, I'm removing the ability to put accessories there, so I'm going to leave that alone. I was also thinking about maybe putting an LED in this. I could maybe drill that out, stick like a 5 millimeter LED in here, and then maybe fill it up with some hot glue, like some white, opaque hot glue. So when the LED shines, it gets diffused by the hot glue, so you get like a nice even white light coming out of there. So I think what I'm going to do is I'm going to start unscrewing stuff here. Before I do that, I'm going to take a few pictures for reference, so when I start to put things back together, I'll know how they're supposed to go back together, hopefully. Okay, I think I'm going to begin by taking these 3 screws off, which should hopefully release this plastic piece. What kind of connection there are to these pogo pins? I'm guessing they're attached to a PCB that's in here. And I'm guessing there are going to be wires going down from that PCB that come up here. So I got to be careful after I unscrew this, pulling it out, because I don't want to break any wires. Yep, see those wires down there? And we see 1, 2, 3, 5 wires. Oh, you know what it is? You know why it's 5 wires? It's 2 ground pins, I bet. A ground that goes to these two LEDs, and a ground that's going to go to that LED as well. Alright, that makes some sense. And I'm going to continue removing more screws here for this shroud that's going to cover the LEDs. So let's get that shroud off. Is it going to come off? It looks like this piece, or is that... What's holding that shroud in? I think these 2 screws need to come out as well. Can't be that, right? Maybe it is. I can see it needs to slide, and it needs to slide up, but something seems to be holding it from sliding out. Okay, so what was definitely holding this in, this piece of the shroud here, was this little piece over here. I don't know how to, still don't know how to get it out, but I pulled it up high enough that I could get this little tongue, or whatever you want to call that tab. I can get it underneath and out. Okay, so I just pushed real hard on the front of this, and I got it to come out. You can sort of see that there's a plastic piece that goes over this and sort of captures the ball in the socket here. And it looks like it's glued in place. There's evidence of glue here, so it's probably something like super glue that's just holding that in place, and so that's not going to come out, which would make drilling this out and having a wire come out through the back here a little bit more difficult, because what I would like to do is not... Oh, but see, then what happens if somebody does that and starts twisting it? There's all sorts of potential problems if I were to do something like that. So, again, I'm going to need to sit and think a little bit here about where to put that extra LED now. A couple days has passed since I first took apart the head. I wanted to think about this a little bit more. I needed to do a little bit more research. The way the LEDs in the head are being powered is there is one of these pins here. It's one of these two pins on the top, actually. Gets 5 volts from the body of the droid. And that 5 volts comes out here through these brown wires and connects to each of these PCBs here. And then to turn on the LEDs, the 5 volts flows through the LED, through a current limiting resistor, and out another wire back into the droid, which connects directly to a microcontroller in the droid, the sound or the personality chip processing microcontroller. And that microcontroller just pulls that pin to ground. And when it does that, that turns the LED on. The problem is there's a limit to how much current you can put through those pins on the microcontroller. And because we do know what the processor is, the microcontroller, it's a General Plus GPCD 9T something 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 something. You can go online and get the datasheet for it and see what kind of rating it has for the amount of current these pins can sink. And it turns out that it's about 30 milliamps. It's probably really should be shooting for 20 milliamps. And so if we look at these LEDs here, we have LED and resistor, LED and resistor, LED and resistor. The resistor limits the current, and we can calculate the current flowing through the LED if we know the value of that resistor. And as luck would have it, it's printed right on the transistor for us, or the resistor I should say. For example, the one by my thumb here says 121. That's 1, 2 followed by a 0, or 120. It's a 120 ohm resistor. That LED, I know, is a blue LED. Blue LEDs typically have a forward voltage of about 2.83 volts. We now have enough information to calculate the current going through that LED. So it's going to be 5 volts, which is the power coming through from the body of the droid. Subtract from that 5 volts the forward voltage of that LED. I'm going to do 2.8 volts here. We get 2.2 volts. Divide that by the resistor value, 120 ohms, and we see we are getting about 18.3 milliamps running through that LED. And if I look on the other side here, it turns out that it seems like about 20 milliamps was the target for each of these LEDs. So that's right up at the limit of the amount of current the microcontroller inside the droid is really prepared to sink. Which means if I want to add another LED here, I can either put it in parallel with the LED itself, so that the two LEDs share that single current limiting resistor. That gets a little tricky because now I'm going to have to solder wires directly to the pads on either side of that LED. Those will be visible through the little smoked plastic here that you can see. This actually comes out. I just knocked that off like so. And it could get in front of the LED and block the light coming out of it. You might be able to see it through this. There could be some issues there. I would prefer not to do it. If one of those LEDs should just happen to fail short, meaning electricity goes right through it, then that means that both LEDs will suddenly be out, because all the electricity that should be going to both LEDs is now all being being conducted through the one LED. There's other reasons here to not want to put a second LED in parallel with the one that's on already. So that means that if I'm going to add another LED, an LED that shares the same power source as this LED here, I'm going to have to do a couple of extra modifications. I'm going to need to remove that the current limiting resistor, it's on the right hand side here, and replace that with something larger. That says 120 ohms, so maybe something around 220, 240, 270, somewhere around there, so I get about half of the electricity that's flowing through it right now. So then I need to find another LED, the one that I'm going to put in parallel to that, which is going to be probably this one here. This is a white LED. This has a forward voltage like the blue one of about 2.83 volts. So I'll need something like 220 or more as a current limiting resistor for this. I've got a couple 220s here. I've also got a 470. I may actually go with the 470. That'll bring the current going through that LED down to about 5 milliamps. It'll still be plenty bright. It just won't be drawing as much current as maybe this thing is on its own right now. What else? Where am I going to put the LED? So what I've decided is I'm going to put that LED in here. And I'm going to drill this out, put the LED in here, and then fill this with some white, opaque, hot melt glue. That is the idea that I've had from the beginning, and I think I'm just going to stick with it. However, you know, if somebody comes in here and moves this around, especially if they rotate it a lot, that's going to tangle up the wires that are coming out the back here. So what I'm going to have to do is glue this in place. I'm going to take this out, which you have to push on this. Once you remove the two screws, you have to push on this to snap it out. There it goes. I am going to probably stick some glue, some hot melt glue most likely, I think right around here. So that way the ball is sort of locked in to here. Or maybe I put it in the back here when I drill through this to get access to here. I'll have to figure that out as I go along, but I think that's the plan. Find the right position for this, which is going to be in here like that. So I want it about where it is right now. I want it about there. And then I'll just have to drill that out, glue that, run some wires, etc., etc. And the wires will have to come out through the back of this, which is located here, and then it'll have to go into the shroud that's covering all the wires here. Let me get these two little PCBs out. They're not glued in place, they're just sort of a friction fit. So these will come out if you just sort of pull up on them, but be gentle, don't break them. Like I'm almost doing here, trying to get this one out. There we go. So this piece is going to be sort of covering it like so. Here is where the eye is going to be, or that the new LED is going to be, I should say, and I'm tapping off of the LED that's in here, the blue LED, so the wire will probably come down through here, still in the shroud, and then I'll probably make a hole right about here. The wire will come out through the side here, and then it can come over to where the where this thing is. So one more thing I want to show you real quick. I'm going to just plug this into the top, like so. Have these just sort of dangle for the moment. And they sort of have the single blue LED on the left and the red and blue LEDs on the right. I'm going to turn this on. Turn on the remote. And maybe if I turn the light off here. We have 3 LEDs here. Something you're going to need to think about if you're trying to add another LED to your R unit's head is which LED, because in an R unit, all 3 LEDs behave differently. And you notice that blue one over on the left here, that blinks a lot. It only blinks during that one particular sound. All the other sounds, it just turns on and then it fades out. That's why I've chosen that one, because in my head this is going to be like the projector sort of thing that, you know, shoots out an image. So I like that fading out as the message or the signal ends, it fades out. That's why I'm tapping into this one. If you wanted to tap into the one of the 2 on the right, you'll see the blue one just is always on, and then the red one turns on and off in relationship to the audio that's playing. So you have 3 different behaviors, and you have to pick which one you want and tap into that one. Also, how do you tap into it? Well, that's a fine question. You could try soldering a wire down in here somewhere. I'm going to just suggest that you don't and not even bother unscrewing this. I've noticed that every time I unscrew this and then put it back together, one of these LEDs stops behaving correctly, and I think it's a contact issue with the pogo pins. So it's working right now, and so I don't want to touch it any more than I have to, so I'm going to leave those alone. I'm not going to tap off of that, which means I have to tap off of one of these 2 very tiny PCBs. Now I could, for example, to get power, I'm going to go into this one here. I could maybe just, you know, separate these 3 wires. You can see they're 3 wires and they're sort of held together. The plastic sheath that the wire is in, the insulation is sort of together, stuck together, but you can pull it apart pretty easily with your hands. I could do that for the brown wire down to here, disconnect that, you know, cut it right there, and make like my own little mini plug, or just, you know, create like a 3-way solder joint there. So I have the power going up to here, and then another one tapping off to go to the LED. That's one way to do it. It means you don't have to touch that LED up here. Or you have to tap into the PCB itself by putting wire running off of these joints here. Which joints go where? And my goodness, how tiny of a PCB is that to begin with? Yeah, there are some questions here about how I'm going to do that. My thought was just to reflow the solder on these joints here and tap off from it using some very small wire. I've got 30 gauge wire here. I was thinking of using that. I might even go smaller if I can find some. I mean, the wire that they're using here looks even smaller than that, and you can get away with very small, very thin, small gauge wire here because there's not a lot of current. As we did the calculations, we're talking about 10-20 milliamps max traveling down each wire, so you can get away with very thin wire. Okay, slight change of plans. What I think I'm going to do, instead of trying to manipulate the incredibly small components that are already on that board, I'm going to leave those alone. And I'm just going to splice into the wires coming down here. So which wires am I splicing into? There are 3 wires. Brown is the power that's coming in. And then I have red, which goes to the LED. The orange wire is actually going to this 1 kilo ohm resistor that's labeled DET for detection. So what I want to do is I want to find a place somewhere down here. So I'm just going to start separating the wire here. About halfway down. And I'm just going to cut right there and strip both ends, and I'm going to stick on the red wire here, which goes to that blue LED. I'm actually going to put just a 100 ohm resistor in series with this wire. That way, that combined with the 120 ohm resistor that's already there will give me 220. That's going to cut down on the amount of current flowing through that LED there. So that means that I don't have to swap this surface mount resistor out, which looks like an 0603 component. If you want to take that route, go right ahead. There's no reason that would be a bad idea. It's just it's such a small PCB that I don't think I want to bother getting into the business of manipulating it. And then on the positive side here, on the brown wire, I'll need to, as I said before, tap into it and have a wire coming off of it. The same over here. I will need, what I'll probably do is, do I put the 100 ohm resistor here and then tap into it here for where the 2 wires that go to the new LED? I think that's the plan. Okay, let's go for it. Snip. Snip. Alright, no going back now. Alright, so now I'm trying to strip a little bit of the insulation. I don't know, maybe a quarter to an eighth of an inch, probably an eighth of an inch. I am going to tin those now while they're still freshly exposed with solder. What that means is I'm going to just melt some solder onto the exposed wire. Why am I doing that? It serves a couple of purposes. You put solder on it now, it sort of holds the stranded wire together so they don't start sticking out and going every which way. Another thing it'll do is it makes forming joints later easier, because all I'll need to do is just touch the iron tip to the wire and the solder that's already there will flow. And if I do that, if I tin, the resistor or any other wire that I'm attaching to this ahead of time as well, I don't even need to add extra solder. I just touch the tip to where the wires join and the solder will flow and melt and forming a join. Okay. I didn't look ahead of time. I should have swapped tips to something a little bit smaller, but that's okay. The insulation is melting a little bit, so it's sort of shrinking, exposing more copper. That's fine. If the exposed wire if there's too much exposed wire, you can always trim that back later. And this last wire here. That should give me some tinned leads. Good. Okay. And I need some heat shrink before I put the resistor in place. Otherwise, I won't be able to put the heat shrink on after. I'm going to trim the lead ahead of time here of this resistor by quite a bit. And I'll tin it. And does this heat shrink fit? No, it's too thin. So I'm going to need slightly bigger heat shrink. Okay, so this is the negative side. I'm going to grab a length of black wire here, strip it, tin it, and form a connection. So this black wire is where the current comes out of the LED through this wire back to the main body. It needs to be after that resistor that I'm putting into it, and it also needs to be connected to this joint here. You have the wire that I soldered to is now going back to the board. This black wire is going to go off to the LED, and now I need to connect that to here. Yeah, good enough. Good enough. So that'll cover that. Black wire will go off to the LED. Now I need to do something similar with the brown wire. Pre-10. Good enough, I think. I just want to do a quick proof of concept. So I'm going to wire up the resistor and LED to these, and then plug it into the head, and let's see if the white LED turns on like it's supposed to. Doesn't really matter which leg I solder to. The resistor can go on either side. Not the final join. This is just enough so I can hook this up and see if it actually works. Okay, LED's hooked up. Let's see if it works. It doesn't have to be pretty. All I care about is whether or not this stuff works. Yeah, good. That'll do fine. Okay, so I went ahead and put some heat to these heat shrink pieces to sort of cover all the exposed wire there. Maybe I didn't entirely cover it all there, but that's okay. That'll be fine. So now I'm going to put this off to the side for the moment, and I need to look at this, which I've already started chewing away at. I wanted to see if that black was it a sticker or was it paint, and nothing peeled off, so I'm not sure what that is, but I'm going to drill that out. So I need to hold it with a vise, so I need to go find that, and then I need to get my drill. Trying to put this in a vise, I couldn't. It's an awkward shape. I'm going to try and go very slowly with the drill here, holding it with my hand, which is just inviting disaster. This is probably not the way I should do it. You can also see how the head moves around a lot. I should probably not be using a drill. And I was hoping that was going to be hollow. It does not seem to be hollow. I think I have to glue this before I drill it. I'm going to glue it. So the hot glue is in place. I heated everything up with the hot air station just to help it melt a little bit more. It's pretty solid, but the plastic is still a little warm. It's a little chewy. So I'm going to go right into drilling here because I'm getting better results with the plastic a little bit warm. And it's just be careful, go slowly. I'm really mostly concerned right now just removing a lot of material. The hot melt glue is not holding it in the socket very well, or holding this thing in place. You can see it still moves around. So probably should have used something like super glue. Okay, so at this point, it looks like a hot mess. I'm going to do a lot of this hollowing out And I might go find a larger drill bit and to attack this even more. The hot melt glue has been removed because it wasn't doing anything. So, I don't know. This is all experimentation. Alright, so while I was working on this, I wound up snapping this. You can see it's broken right there, but that allowed me to pull the inner ball out, which I think is actually beneficial. So I can fix that later. Again, my plan is to have this whole thing glued together so it can't move. I'll use epoxy or super glue or something. Hot melt glue isn't really doing anything. Anyways, I have drilled this out, and if I take an LED now, it fits all the way down there, like so. So there's the mod. So what I want to do is put a thin layer of opaque white hot melt glue over this just to make it look a little bit more interesting. And then I think I'm pretty much ready to reinstall everything. Well, I'm going to have to glue everything back together, and that's going to take some time. But let's see what we can do, shall we? So here's this whole harness that I have going on right now. And I just want to sort of put this in like so. And I want to fill this all up with hot melt glue. Yeah, that's about what I want. And this will take a couple of minutes to cool down, but maybe we can get a preview. Yeah, that's pretty much what I wanted. Good. I am going to let this cool and then figure out, probably put this in here. I'm going to need to make this hole much bigger and go from there, I guess. So I've put in a bunch of super glue there, and it needs to settle. So I'm going to leave this alone for, I might leave it alone overnight. It's kind of late, but I can put this into my LED tester here. And that's about the brightness it's going to have when it's in the thing. So I'm pretty happy with that. It's diffusing the light well enough. It's not perfect. If you get up close, you can see how, you know, there's like some clear glue along the edges here, because I had clear glue in my hot glue gun before I put the solid white in, and so it doesn't look perfect. But you know what? From far away, it'll look fine. I filled in the hole with some hot melt glue just to help keep these wires separated. So now the next step is repackaging all of this. So I've put the two PCBs back where they should be. Here are the splices with the two wires, the red and black wires. These need to exit out somewhere, probably about right there maybe. And what they will do, they'll exit about here, and then they'll be able to come up and attach there. Yeah, that's all it is, just a groove. It's going to allow the wires to come out while this remains flush with the dome, and that should do fine. So I'll grab a file and smooth the edges out there. So a little Captain tape to sort of help the wires stay in that groove. To the dome we go. There we go. I think we're good. And then these wires need to be about that long. I don't need to have this installed when I'm soldering these wires. I could take all of this out and solder the wires to make my life a little easier. But for whatever reason, I've decided not to do that. So I'm going to try and hold the wires up like that. I'll go with some green heat shrink on both wires. And I'm going to try to solder the resistor to the wire. Good enough. Okay, so the LED's wired up. Oops, I need to do the heat shrink so that way the resistor and the wires here don't risk touching. I'm going to go do that real quick, and then I'll slap this in. We'll put the head back on the droid, and hopefully everything works. Heat shrink has been shrunk. So now I'm going to put this back in, and hopefully it fits still. Now this sticks out quite a bit, so I'm going to need to bend that. Now we have the leads of the LED there, so I should be able to bend that without really any issue. Alright, now I want to do a quick test fit. I'm looking, for example, at this place here which sticks out. I'm assuming I have plenty of space because the wires aren't sticking out further than that nub, but I don't know. Well, this is all brand new. I've never done this before. We'll find out together. Of course, be careful when you're screwing all of this stuff back in. You're screwing into plastic. It is very easy for you to use the screw to inadvertently create new threads in the hole and wind up with stripping the hole, stripping the threads, and the screw no longer fitting. So the trick to help protect against that is to put the screw in the hole and screw backwards. Screw counterclockwise until you feel it fall in, and then screw clockwise, and the screw goes right in, and you don't have to worry about any issues with the threads. Alright, let's turn this thing on and see what happens. Works great. There's one subtle problem. I've got the LEDs swapped here. So I gotta put that back together, or take this apart so I can swap those. And I don't like how I can see some of the glue along the edges here. That's a little irritating. I don't know how I'm gonna fix that though. I think I'm just gonna have to live with it. Alright, so I gotta take this head apart and swap those LEDs because I did it backwards. I have swapped the LEDs, so now they're where they should be. I've added some tape here to hold those wires down so they don't dangle anywhere. So now it's time to throw the dome back on and prove that the LEDs are the right way around. Here we go. Yeah, that doesn't look too bad. So if I were to start over and do this mod again, is there anything I would do differently? This, I would probably just go right ahead and break the inner piece out where I snapped it by accident so it came loose, but I would have broken it out immediately. It just makes the whole process easier. The glue gun, I would have gone through a couple of white sticks before I started using it on here to get rid of that little extra clear glue that was still in the pipe when I started using it. So I wouldn't have this sort of muddy looking edge around it. I don't kind of like that. I might try and come back and reheat that with the hot air gun a little bit, but for the most part it's fine. I am happy that I chose to splice into the wires instead of trying to solder to those PCBs. I think soldering to those PCBs or trying to change out that resistor that I was looking to increase its value of, I think the way I did it was the right way. It just removes a lot of very fine soldering that can go wrong. Other than that, I think that's it. So while, yes, of course it is possible, you can add an extra LED or two or whatever to your R-unit dome, I am going to say you probably shouldn't. I don't think it's worth it. You're With the BB units, you have a little extra play there. You can draw more current. You don't have to worry about the current you're drawing, really. But with this, you absolutely do. If I added a couple more LEDs, I'd have to change all the resistor values or keep adding resistance so that way the current draw isn't too high, because again, we have like a 20, you can maybe push the 30 milliamp limit on how much current per pin, or per LED pin, I should say. There are 3 LED pins for the domes of our units. So I think you probably want to stay under that 20 milliamp level range, whatever you want to call it. So adding more LEDs means fiddling around with resistor values and stuff. It gets a little complicated. You can't just throw in an LED and you're done. There's a little extra thinking that needs to happen there. Because if you do it wrong, if you draw too much current, or I should say if you sink too much current, you risk breaking or damaging the microcontroller that handles all the sounds and the personality chips and stuff like that. Best case, the LED pin just breaks and you can no longer drive those one of these LEDs stops working. Worst case, the whole chip breaks and now you're without sound. You'll still be able to move it. A separate microcontroller receives commands from the remote and drives the motors, but the sound would go away and that'd be kind of disappointing. So I think that's it. That's the mod. This all began when somebody asked, could I do a video modding an R unit dome? And this was a mod that I had been thinking about for a little while, so I decided, what the heck, why not? And I'm glad I did it. It was a good experience and good to share, I think, but I don't think I would do it again. I would probably choose to leave my R unit domes stock. But you can choose to do whatever you want with yours because it's your droid. So that's it. Have fun.